Welcome to Singapore Junior Physics Olympiad 2012 General Round Question 16. A tractor moving forward at uniform speed on a horizontal ground has a front wheel diameter of 0.8 meter and back wheel diameter of 1.25 meter. The horizontal distance between the axles of the two wheels is 2 meter. During a trip, a pebble stuck to the front wheel flew off the wheel at the highest point. 0.2 seconds later, another pebble flew off the back wheel at its highest point too. The two pebbles landed on the same spot on the ground. Find the speed of the tractor. The options are A. 3 meter per second, B. 5 meter per second, C. 8 meter per second, D. 10 meter per second, or E. 12 meter per second. So to begin answering this question, we first look at the motions associated with a wheel. So the first motion is due to the velocity of the tractor itself. And as a result of the velocity of the tractor, each point of the rim moves to the right at the velocity of the tractor. Next is the motion due to the rotation of the wheel. And because of this rotation, each point at the rim of the wheel will have a velocity in the direction as shown by the red arrows. Now to proceed, I would like to introduce two forms of motion associated with a wheel. The first is the skidding motion. So as you can see from this animation here, a wheel undergoing skidding motion do not rotate. Like the name suggests, it just skid on the floor. Next is the rolling without slipping motion. As you can see from the animation here, the wheel rotates while moving forward. So if you look at the bottom point of the wheel for the skidding motion, this point actually moves from here to here and is skid across. So we can say that the velocity of this point is actually not equals to 0. Now comparing this with the rolling without slipping motion though, this point from here, it does not skid across the surface. Right? So this point is actually stationary at the moment touching the ground. So the velocity of this point is actually equals to 0. And we know that the motion of the wheel of a tractor is a rolling without slipping motion. Therefore, the velocity at the bottom point of the wheel is actually equals to 0. Now, if you look at the velocity at the bottom point of the wheel, we can see that there are actually two components at the opposite direction. On the right is a V tractor, on the left is a velocity due to the rotation. And since the resulting velocity must be equal to 0, we can say that the rotational velocity and the tractor velocity must be equal in magnitude. Now, with all these concepts, we can proceed to answer the question about the pebble flying off the wheel. The pebble flies off from the highest point of the wheel, as shown here. Now, from what you can see is that the pebble, the moment it flies off, is going to have the velocity at the top point of the wheel. So, at the top point of the wheel, it has the velocity due to the rotation component as well as the tractor component. And since they are in the same direction, we just add them up. And from this equation, we can see that the velocity of the pebble is actually 2 times the velocity of the tractor. So, the pebble has two components of velocity. First, the horizontal component due to flying off the top point of the wheel, and also due to the gravitational force pulling it down, it also gains velocity in the y component. So let's study the motion of the pebble flying off the front wheel of the tractor. So the distance which the pebble fly off is equals to the velocity of the pebble, which is 2 times the velocity of the tractor, multiplied by the time spent on the air. As for the y component, we know that the pebble actually travels a height equivalent to the diameter of the wheel. And since there is no initial velocity in the y direction, the distance traveled is all contributed by the acceleration term. And next, we move on to the pebble flying off the back wheel of the tractor. So the pebble from a back wheel lands on the same spot as the pebble on the front wheel. So we have this x term here, which is the distance traveled by the pebble from a front wheel. But this time we need to add the distance of the axle connecting the front wheel and the back wheel. And because there is a time delay from the pebble flying off the back wheel compared to that of the front wheel, we also need to minus off the distance traveled by the tractor due to the time delay. So again, this is equal to the velocity of pebble multiplied by the time spent on the air of the pebble. And likewise, the height traveled is from a highest point, so the height is equivalent to the diameter of the back wheel. So by rearranging all these four equations, we can get the final equation on the velocity of tractor as shown here. Now the values of all the parameters shown in this equation is given in the question as shown here. So by substituting all the values into this equation, we get the final answer of the velocity of tractor being 5 meters per second. Therefore, the answer to this question is B, 5 meters per second.